Following Wednesday's class, we talked about edge detection, and that is one of the most fundamental things in image processing. And that's the reason that we have been talking about Gaussian filters and blurs in the first place. Generally, we take an image and we transform it from color to black and white. We get rid of the noise using a Gaussian filter. Then we will try to find the edges in the picture. Now, there are many different ways of doing it. We start with the most simplest way, and I think the simplest way is to use a gradient-based method for calculating the edges. I didn't realize this at first, but it just occurred to me how intuitive the derivative way of calculating gradient makes a lot of sense. If you can see the intensity of the image from low to dark, if you can see that big change, then there must be an edge there. So all you have to do is to look at the change in the graph intensity. Then you will be able to get the edges. So the simplest way to do that is using a Sobel method. And this is invented by Sobel in 1965. And basically what it does is it finds the partial derivative of the image. But the partial derivative of the image has to be split into the horizontal direction and the vertical direction. I didn't really understand this at first. Why would there be two filters? And why would I look at things from a horizontal perspective and from a vertical perspective? I mean, if you think about it, if there's an edge inside a photo, if I look at it from a horizontal perspective, and if this edge is horizontal, there's no edge. It's simply a dot. But if I look at it from a vertical perspective, then clearly I can see this change in intensity. Now that's an edge. So in one perspective, the horizontal perspective, there are some edges. And in the vertical perspective, there are some other edges. And when we put the horizontal perspective and the vertical perspective together, then we find all the edges in an image. And that's why we do the partial differentiation of the image with respect to x and the partial differentiation of the image with respect to y. Then that's when we get the magnitude. After we find the magnitude, we also need to know the direction of the edge. And if you think about that, if you have an edge along the x-axis and you have an edge along the y-axis, like a triangle, how would you find the direction of the angle? Well, this goes back to high school math. We simply use the arctan, the inverse tan of the differentiation with respect to x and y, and that would give us the angle that the edge is running across. So we would know the intensity of the edge through the calculation through the Pythagoras theorem of x squared plus y squared equals the square root of x squared plus y squared equals to x squared plus y squared equals to z squared. So if we square root that, then we'll get the magnitude of the edge that we're looking for. And the direction is calculated using arctan. And that's how we find an edge. And all gradient-based filters work similarly. Sobel incorporates Gaussian-like filters, so that will have focus more on the center, whereas prewitt do not have a Gaussian spread in its kernels. So those are the differences between Sobel and prewitt.